Hello everyone, welcome back to our Python YouTube channel. Today we are discussing with the major topic while loop in Python. So, let's start with our next topic. Until now, every program that we wrote executed only once. For example, if I want to print welcome to Python, for example, if I want to print this only one time, we simply write welcome to Python. It will print only one time. So it will print only one time. Now imagine I want to print this message 100 times. Should I write the print statement around 100 times? So it will take much time. So a loop allows us to repeat the same block code multiple times without writing it again and again. It provides us two loops. We will use while loop and for loop for this. So now we will learn about while loop first. So I'll give you a simple definition. A while loop is used to execute repeatedly as long as so this is the simple definition. Let's see the syntax for this. So after a while we will write the condition, what the condition is. Next, we will write the statement. So this is the simple syntax for the while condition. So the while loop has two important parts. The first part, as we seen, is condition. The second part is body of the loop. So Python first checks the condition. If it's true, Python executes the loop body. After completing the loop body, Python again checks the condition. This process continues until the condition becomes false. Once the condition becomes false, Python exits the loop. So now we'll take with an example. So if I want to print 1 to 5, let's print it. Suppose I equal to 1. Now let's write while. After that, we'll write the condition I less than or equal to 5. Then let's print I. Later, we'll write the. So we have already learned about this in the previous lecture. So let's run this. So it printed 1 to 5. So this is the use of while loop. So now we'll explain step by step. So in the first line, we wrote I is equal to 1. So this variable is called a loop control variable because it controls the loop. Now Python checks the condition is true. I less than or equal to 5 here. So yes, 1 is less than or equal to 5. So the condition is true. Therefore, Python enters the loop and prints 1 here. It prints 1. So after printing, we'll write I is equal to plus or minus 1. So the value becomes 2. In previous, we know that value is 1. No? So I is equal to 1 plus 1. So the value is 2. So now it will again check this condition 2 less than or equal to 5. So this condition is true. Now it will print the I. We know that I value is 2. So it will print 2. Like this, it will check the condition until 5 if I is equal to 5. So 5 less than or equal to 5. It's true. So it will print 5. Later I is equal to 6. So at the same time here 6 less than or equal to 5. So the condition is false. So the loop is stopped here. This is how the while loop will print. While loop will work. Now let's see the different type of examples. So let's print odd numbers from 1 to 9. Suppose I is equal to 1. Now while I less than or equal to 10, print I plus 2 will write because we want odd numbers. Yes, it prints 1, 3, 5, 7, 9. All odd numbers 1 to 10. This is also like what I have explained before. Like I equal to 1. So 1 is less than or equal to 10. So the condition is true. Now it will print the first. So now it will print the 1. Next, it will enter to I is equal to I plus 2 means we know that I is 1. So I equal to 1 plus 2. So the value will become 3. So it will check the condition. So 3 less than or equal to 10. So the condition is true. Now I is equal to 3. So it will print the 3. Like this, it will print later if the value of I is 9. So 9 is less than or equal to 10. So of course it's true. It will print 9. Next, I equal to, we know that I value is 9 here. So 9 plus 2 means the value is more than 10. So here 11 less than or equal to 10 means so the condition is false. So the loop ends here. So the last loop ends with 9. This is how loop work. So now I want to print reverse counting from 10 to 1. So let's print, suppose I equal to 10. So while I greater than or equal to 1. Now let's print I and I equal to I minus 1. Yes, 10, 9, 8, and 1. So our numbers increase until now. Now we have print this in reverse order. So according to this, now Python checks the now loop starts with I equal to 10. No, next step Python checks whether 10 greater than or equal to 1. Of course, this condition is true. Now Python prints 10. Now it will, so here at the starting Python prints 10. Now in the next condition, I equal to I minus 1 means 10 minus 1. So that value will be 9. So 9 greater than or equal to 1. So it will print 9. Yes, it printed 9 here. Now again, I equal to 9 minus 1 will be 8. So 8 greater than or equal to 1, it will print 8 here. So like this. This is the reverse condition. It will print. If the condition becomes false, then the loop will end. So Now let's see the multiplication table. Suppose let's take a number input is equal to int. So let's take I equal to 1. Now let's write the while condition. While I less than or equal to 10, let's print num. Let's run this. So if I enter 5, of course it prints 5 table up to 10, up to 5 times. So I will explain this very clearly. Suppose if I enter here 5, so now Python stores the integer 5 in the variable num. Here we have taken as variable at the starting. So then it will initialize, it starts with I is equal to 1. So Python checks 1 is less than or equal to 10. So condition is true here. Now it calculates before we have taken this as 5. Now 5 into 1 equal to num into I. Num into I means num stores 5 into I. I value will be 1. So 5 into 1 will be 5. So later I value increase here step by step. So now here after this, here I will become 2. So 2 less than or equal to 10. So 5 into 2 will be 10. Like this up to if I is equal to 10, 5 into 10. So the value will be 50 like this. So after 10, the value will be 11. So 11 less than or equal to 10 means false. So the condition here loop will end. Like this, it will print up to 10. What we it will see the condition what we have given before. So until the given condition is true, the loop will run. If the condition fails that, then loop will end here. Loop will stop. So now let's see with another example. Let's say the factorial based example. Suppose let's take suppose let's take fact is equal to 1 and I equal to 1. Let's start with I equal to 1. So while I less than or equal to n, suppose 1 is less than or equal to 5. So fact is equal to fact into y. Let's print the result. So factorial means we already know about factorial means suppose 5 factorial means 5 into 4 into 3 into 2 into 1. So it will print until 1. Suppose if I want to calculate 7 factorial means 7 into 6 into 5 into 4 into 3 into 2 into 1. Like this factorial will work. Now let's see this problem. Let's run this. Suppose if I enter here, suppose if I enter 5. So the result is 120. Yes, 5 into 4 into 3 into 2 into 1 is equal to 120. Initially, we have taken fact is equal to 1 means factorial is equal to 1 and I is equal to 1. So in the first iteration here taken, we have taken here 1, I is equal to 1 and we gave here number 5. So 1 is less than or equal to 5. So the condition is true. So factorial means we have taken 1 into 1 means it is equal to 1. So in the next condition, I will becomes 2. So here again 1 into 2. Again, yes, if the condition is true, then we will go to the next step and factorial. We know that previously 1 into 2. So the answer is the previous here we know that 1. Factorial value is 1. Again, if I value becomes here 2. So 1 into 2 means factorial value is 2 here. Remember this. Factorial value is 2. Later again, I value becomes 3. So here again, 3 less than or equal to 5 because we have entered 5 as the input. So I value is 3, but factorial value is 2 because previously we have calculated. So again, 2 into 3. Answer is 6. Now factorial value is 6 here. Like this, it will print until the condition is true. This is how this factorial variable is going to work. Again, if I enter some suppose 6, then 6 factorial will be 720. This is how this we are going to write a code if I want to calculate factorial. So key points to remember, a while loop repeats a block of code as long as condition is true. Always update the loop control variable like I is equal to I plus 1. Otherwise, you may create an infinite loop. If I didn't create this, suppose may create infinite loop. So this will it will work for previous examples. So you use a while loop when you don't know in advance how many times the loop will run or when repetition depends on a condition. So now let's start with a more advanced while loop applications. So I will tell you four more problems which may usually ask in your examinations. So if I want to reverse a number, reverse a digit, let's take in num variable int input enter your number. So suppose I'll take reverse is equal to 0. We have to initialize this before the starting. Suppose while num is greater than or equal to 0, then we will write the condition. Suppose digit equal to divided by 10 and so let's run this. So so now our task is to reverse a number. Suppose if my number is 1234. So if my number is 1234, suppose if I enter here 1234. So the result is 4321. This is how it will reverse. But before that, I will explain you clearly. So let's see our first iteration. So here we have to enter the input 1234 And next line is reverse is equal to 0. So 1, 2, 3, 4 greater than 0. This condition is true. Now let's see digit is equal to num means we know 1, 2, 3, 4. 1, 2, 3, 4 modulus 10 means you know the remainder will be 4 because 1, 2, 3, 4 modulus of 10 is of remainder will be 4. So let's see the next line. Here reverse means reverse we have initialized before at the starting reverse is 0. So reverse into 10 plus we know here digit is 4 because 1, 2, 3, 4 modulus of 10 means it will give remainder. We have learned about this modulus in previous lectures. If you have not seen, you can go back and you can visit those lectures. So modulus means it will give reminder. So 1, 2, 3, 4 modulus of 10 means so our digit number will be 4. So here reverse into 10 means actually we have learned about this order also. First we will give priority to this multiplication. So reverse 0 into 10 means 0. 0 plus 4 means so the reverse is 4. So later again we know that num is 1, 2, 3, 4. So 1, 2, 3, 4 if we use floor division for 10 means with 10 means it will give the last digit means it will remove the last digit. It will give 1, 2, 3. We have learned about this floor division in previous lectures. So so now here our num is 1, 2, 3 at the starting and again 1, 2, 3 model of 10 means it will give them reminder. So our again our digit is 3. So previously we know that our reverse number is 4 at the starting in first iteration. So 4 into 10 40 plus here our digit is 3. So 40 plus 3 is 43. Again 1, 2, 3 floor division with 10 means it will remove the last one. So wall 1, 2. Again here 1, 2 greater than 0. So 1, 2 modulus of 10 means our remainder is 2. So here our 43, our reverse number is 43 into 10, 430 plus here our digit 1, 2, 3, 1, 2 module of 10 means 2. So 430 plus 2, 432. Again 1, 2 floor division of 10 means it will remove the last digit. So our number is 1, 1 greater than 0. So 1 module of 10 means 1. So 432 into 10, 4320 plus 1 means 4321. So here the loop will end because 0 again 1 floor division of 10 means 0. So 0 greater than 0. So the condition is false. So our last reverse number is 4321. So directly it will print the next digit 4321. So our result is 4321. This is about reversing. So I have explained very clearly so that you can understand this. So let's start with our next question. So let me see this whether it's recording or not. Yes. So our next program is let's count the digits. Suppose if I take input is equal to int So suppose I want to initialize the starting count equal to 0 while while n greater than 0 equal to n equal to n floodation with 10. So let's print result equal to count. So this is about count how many digits are present in a number. Let's run this. Suppose if I enter here 98765. So the result is 5 because 98765. There are five numbers. So the result is 5. This is how this count program will work. I will explain this clearly. So at the starting, we have initialized this count equal to 0. So every time we remove one digit using floor division with 10, it will increase the counter by 1. So I will explain this. Already you know about this, how it will work. It will remove one digit at the last. So my first number is 98765. Here I have entered. So count is equal to 0. 98765 greater than 0. Yes. Now count equal to count plus 1. Previously we know that count is equal to 0 plus 1. So count is 1 here. Later again in 98765 with flow design means it will remove 5 last digit. So n will be now 9876. So 9876 greater than 0 here. So again count equal to previous we know that count is 1. So 1 plus 1 again here. So the present now count is 2. Again in the end 9876 it will remove 6. So 987 greater than 0 count equal to we know that previously count is 2. So 2 plus 1 will be 3. Again here 987 n will be 98. So 98 greater than 0 count will be previous we know the count is 3. So 3 plus 1 4. Again here in 98 it will remove 8. So 9 greater than 0. Previous we know the count is 4. So 4 plus 1 5. So here again it will remove 9. So n will be 0. So 0 greater than 0 means false. So the loop ends here and it will print 5 because we have know that the count is 5 here. This is how this problem is going to be run. So let's take another problem. In this problem, we are going to discuss sum of digits. Suppose I'll take num equal to int input entity number. So that suppose sum equal to 0. Then we write the while after that condition num greater than 0. Then by digit Let's run this. So now our task is to add all digits of a number. Suppose if I enter 456, yes, 4 plus 5 will be 9. 9 plus 6 is 15. Yes, it's working. Now let's see the dry run of this program step by step. So at the starting, we have initialized sum equal to 0. We have entered here number 456. So 456 greater than 0. Yes. So our digit will be equal to 456 module of 10 means it will give reminder. So the reminder will be 6. So sum equal to sum plus digit means sum, we know that previously sum will is 0. Here we have initialized at the starting. So sum is equal to 0 plus 6. So the sum will be 6 in present. So num will be 456 float and 10 means it will remove the last digit. So 45. So our present num is 45 and sum will be 6. So digit will be equal to again 45 module of 10 means the remainder will be 45 module of 10 means remainder will be 5. So our sum we know that previously 6. 6 plus 5, 11. So 45 again 45 module of 10 means sorry float of 10 means it will remove the last digit. So 4. 4 greater than 0. So after this 4 module of 10 means remainder is 2. And this is how it will after this calculation again our digit will be the previous plus 1. Previous plus digit. Sum previous sum plus digit. So at the starting 0 mod of 10 means here the condition will be going to false here. And it will print the our sum. This is how this sum of all digits is going to be work. So now let's continue with our next palindrome. Let's see our palindrome question. Suppose num equal to int input. Let's enter a number. Now let's take original equal to num and reverse equal to 0. Now let's take while num greater than 0. Suppose digit equal to num divided by 10 and let's use here if conditions. If original equal to reverse, then print else not palindrome. So before that, palindrome number is a number that remains the same when we read from left to right or from right to left. Suppose, for example, 121, 1331, 1221. These are examples for palindrome. Suppose if I enter here 121, yes, this is a palindrome number. So we store the value here. Original will be we have store actually first num. So next step we have taken original equal to num. So original value is 121. Then we reverse the loop. After the loop, reverse will be before we have learned about that reverse. So here reverse will be 1 to 1. So if original we have stored at the starting 1 to 1, so 1 to 1 equal to 1 to 1, then it will be palindrome. This is our palindrome question. So in the next class, we are going to discuss for loop. Thank you for watching this video. Let's continue with our next topic for loop in the next lecture.